Okay, so does it make sense why that first series, the one in problem, number one, why it sums to one? Just give me a thumbs up or an indication just so I know. I'm happy to talk more about it, but if I don't need to, then I won't. Like I say, this is a strange object, so it takes some time to get comfortable with. It doesn't, it doesn't happen all at once. So let me ask the question this way, and you can just answer with a yes or a no or thumbs up or something like that. If I gave you just the triangle itself, and I asked you without any of the commentary that I have here, and I asked you to sum 1/2, 1/6 plus 1/12 so far, could you explain why that equals 1? Like if somebody asked you that. Okay. Okay. What I want to do is somebody said that they would like an explanation, so I just want to go over what we're doing. So again, I'm taking everything in that second column, including the 1/2. I'm adding all that together, and I say that I should get 1. Okay. So that's my, and I have it on the paper. That's my claim. Okay. And then I have to look to see how this table is constructed. So I look at 1/2 and I see that 1/2 is equal to 1 minus 1/2. Okay, so I've taken care of that. Then I go to 1/6 and I see that that's equal to 1/2 minus 1/3. Then I go to 1/12. Again, I look to see how it was made. That's 1/3 minus 1/4. And then, sorry, it's 1/12 plus 1/20th, not 30th. So I'll just go to there. Again, to see 1/20th, I see, okay, that's going to be 1/4 minus 1/5. So I get that one. Then I'll do 1/32 since that's not on there. I look at 1/30, and again, using the triangle, I see that that's 1/6 minus 1/5. Okay. So then I look at that and I see that all these are going to cancel. Those are going to cancel. Those are going to cancel. Minus 1/4 is going to cancel, and so forth. So what I'm going to be left with is this plus a very small term. And the more terms that I go, this term is going to go to 0 as n goes to infinity. So because of the cancellation and the telescoping, all I'm going to be left with is that 1. Okay. 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 So I hope that helps. What I'm going to, again, I think I'm going to put you in the groups, and then I'll just, and I would like you to work on problems number 2 and number 3. Again, you'll just take some random stuff to find 2 series that are equal 1/2 and 1/20th, and then try to answer the Leibniz problems. So I'll make 5 groups, okay? And so I'll open the rooms now. Hey, Bryce. Hi, Daniel. I just want to make sure that you're not having Zoom issues getting into the room. Good.
Hello.
Hello. Just gave you the ability to share if you want.
Okay.
Any questions? Did that make sense about why the series is equal to 1?
Yeah, I get why that series is equal to 1.
Uh-huh. I
Is
sent
it
it. Oh, go ahead.
so I'm just trying to think of like how do you be like, yes, this is the series you want to work with. Is it be like how do you define that? Are you like it's the second row of the Leibinz triangle? Is that basically how you would explain it?
Okay, so you look, what I would do is, here, I'll share, and I think it's easier to show you how I would start, how I would answer that. Okay, I hope that's the right thing. I have too many windows open. Is that the right thing? Are you seeing the triangle?
Yeah.
Yeah, okay, good. Okay, so let me get my tool. Okay, so, whoops. Let me try that again. Yeah, okay, good. Okay, so I would just look for a 1/2.
Yeah. Uh-huh.
Okay, and then
And then
everything,
everything below it.
yeah,
Is it everything below it and 1 to the right?
yeah, it's an offset of 1 in each direction.
Okay.
So you go down 1 and over 1.
Yeah.
Okay, okay. Now,
Because
oh, go ahead.
because you then asked for like what 1/20th would be. So could you start at that 1/60th in that column that you just highlighted and be like, that down is going to be 120, 1
Yes,
over 20.
yes.
Okay, how do you specify that?
Oh,
Like how do you
okay,
be like, yeah, this is the series you want to add up?
okay. I would do something like this. Okay, so let's go to 1/20th. So you're using 1/20th, and what's its position?
Oh, right. The 120 is
We're thinking of it as a matrix.
wouldn't it be 5, 2?
Yeah. So I'd say I'm taking the 120 at 5/2, then I go to the 160 at 6/3,
Uh-huh.
because really you could build a computational system out of that. And then I add everything below it. That would be one way.
Okay.
That would be one way to say it. And then another way to say it might be to do something like this, because I would be able to locate it. Like if you had to answer this on a test or something. And then just give me 2 or 3 terms, enough to locate it where it is.
Mm-hmm.
So now I could find it. And I say, oh yeah, of course, that's going to work.
Okay.
Okay.
I think that makes sense.
Yeah. Now how about how about Daniel and Paige? Is that making sense?
Yeah, that makes sense.
Okay, good. Now, how about if I said use this to find a series equaling 1/2? So
Wouldn't
oh, go ahead.
would you just double
Yes,
everything?
yes. That's a big hint for number 3.
Okay.
What do you mean double everything?
Okay, 1/4 is equal to 1/4 is going to be equal to this, right? All those things added together.
Okay.
And what if I just multiply all those things by 2?
Okay.
Yeah.
Yeah. Because I'm trying to think of how we find like all the how we find a thing that's like, yeah, here's all the reciprocals with the triangular numbers.
Right.
Um,
That's 2/5. Right. So so you'll have to, yeah, they're not in there.
yeah.
Yeah. So you have to be clever, creative. Right.
Do we have to like pick multiple different series or how or
Well, maybe you'll find, maybe, I mean, That's a very good question. Leibniz, a good question would be, now any of you had abstract algebra yet?
Yes.
Okay, what numbers could I create from these numbers? Like if I notice if I add stuff up, I have a set of numbers here. And can I approximate any number by this set of numbers? I don't know the answer to this. If I could, then I could create, if I could do it in finite space, say, that would be the question asked, what kinds of things can I sum up? That's a different question. So for your question, what I would do for number 3, I would try to find, I just gave you a hint, and I would look for a single column. Let me put it that way.
A singular column. Okay.
A single column, not like moving in multiple columns.
Yeah. One column.
Right. And it's going to be a multiple, so you have to think about that.
Okay.
And the numbers are 1/3, 1/6, 1/10. So that should help a little bit.
It's like, how can we move those?
Right. Yeah. Can I multiply or divide them, or think about it that way. Yeah.
Yeah.
Okay. So I was going to go look at some other groups, but does that help?
Yeah.
Oh, wait.
I think I see it.
Yeah.
I need to see more of the triangular numbers. I might have found it.
Yeah. And there might be more than one way to do it too. This is one of my favorite things because it's just like nobody really talks about it. I just think it's just such an astounding. I'll talk about that when I get back to the
Do the
class.
triangulars numbers go 1, 3, 6, 10, 15, 24?
Yeah.
Okay, I found it then.
Yeah, it's the summation numbers. Yeah.
Yep.
Okay.
I think I found it.
Okay. Well, I'm going to take off. I'll stop that share. And I'm going to check it in some other groups.
Yep.
Hello. I'm just checking in to see how you're doing in terms of progress, and is it making sense?
Yeah, it's not going too bad. I just you wanted us to do that part where it talks about the number 2 part of like the.
Yeah, number 2 and number 3. Yeah.
Okay, that's what I figured.
Right. And so the idea is that you locate these numbers in the series, in the table. I can go, do you want me to demonstrate that, or do you think you have it?
If you could, I think that.
Yeah, I'd be happy to, yeah. It's a complicated object. It takes a while to digest it. And once you do, you say, oh, good, I got this, but okay. So you're seeing the chart, right?
Yeah.
Okay. So I said I'm going to pick a different number than 1/2. But so let's say I'm going to pick, I was going to say 1/30, but that's what you have that. So I'm going to do 1/20, you have that. So I'm going to do 1/30. And there's a couple of 1/30s. I'm going to look at this one. And the way it works is that I go down 1 and over 1, and I look at the entire column. And so, again, not worrying about why. I would say, okay, that 130 is equal to, I go over to the 160 and it's equal to everything below it. 160, 140, and so forth. So as a black box for computation, that's all we're worried about right now. Okay. But let's say I wanted to find another series. Well, here's another version of 130. Right here. Let's do this one. There's several. And that would be equal to everything 142nd, 168, and everything below that. Okay. So does that make sense?
Yeah, thank you.
Okay, good. Jackson, how's it going? Does that help?
Yes, thank you.
Okay, good. Okay. Yeah. So again, I'll let you work on it for a bit, and then I'm gonna go just visit a couple of other groups. Unless you have other questions, I'll be happy to answer them if you do.
Good. All right.
Okay. Thank you. So see you in a bit. Just checking in to see how you're doing and if this is making sense. A couple of groups have said I've gone over the chart and done a couple of examples, and they said that's helpful. Do you want me to do something like that?
Yeah, I think it might be a little bit helpful.
Yeah, for sure. Okay. Okay. Am I sharing the screen?
Yeah.
Good. Okay. Let me just get my hand, select a tool. Okay. Okay. So let's say I want to find a series adding up to 1/30th. Okay. And all we're interested right now is as a black box. Okay. Not why it works. By black box, I mean you just use it to get an answer, and you're not really thinking about like why it works. Just like when you push a button on a calculator. Okay. So here's a series. Here's 1/30. Okay. And the way this works is that everything in this column sums to 1/30. So 1 over 30, sorry, not 1/30, but 1 over 30 would be equal to this. Okay. Does that make sense?
Yeah, that makes more sense.
Yeah. I mean, this is complicated. Like again, once you'll get a comfort level. If I wanted to find another one, I'd go to this 1/30, and then I would just use this column right here. And then let me show you, this will be helpful for the third problem. But I'm going to clear all this. Is that okay?
Yeah.
Okay. Okay. So give me a number that I can multiply to get 30.
5 and 6.
Okay, let's take 6. So I know that 1/6 is equal to this right here, right? And so forth. Now, what do I need to multiply 1/6 by to get 1/30?
1/5.
Yeah, or yeah. So I do that to the whole series. I get 1 over 30 equals 1 over 60 plus 1 over 150, if I'm doing it right, and so forth. Yet another, okay. So that's legal, that's a legal move too. Okay. Does that help?
Yeah, that helps.
Yeah, and let's focus on this, and then when we come back, maybe I'll talk. I want to talk more about the why, but right now, just try to just be able to manipulate it like you would a calculator or something like that. Okay. Okay, Emma, is this making sense?
Yeah, I'm good.
Okay, Nick, how about you? I'm going to assume that's a yes. Okay, you know where to
Yeah,
find.
it's a yes. I was just trying to
Find the mute button. I'll be yeah.
something like that. Yeah.
I sit there sometimes like talking, and I realize I got the mute button on. Okay. Anyway, so I'll let you work a little bit longer on this, and just play around with it, and think about, once you get comfortable with how it works, try to figure out why. Okay. Okay. So I'm going to go visit a couple more groups, and I'll come back. You got it. Oh, that's the 1/2. Yeah. Yeah, you got it. Not only that, you understand why.
I'm trying to actually do.
Okay.
Yeah,
that's exactly it. Are you alone? Wait.
But I'm looking at Because is it just one series or two series? What do you mean by two series?
Well, okay, here, I'll just do a share. Oh, no, well, I don't want to, I wanted to show you using the paper, but I don't want to take, if you want to keep what you have left, I'll just try to explain it.
No, it's fine. You can just erase it.
Okay, so it's okay to share? Yeah.
Yep.
Okay. Okay. So you should see the triangle?
I see a lot of code. Not
A lot
triangle.
of code? Okay, not seeing the triangle. Okay, let's try again. How about now?
Yes.
Okay, I know what I did. I just hit the wrong screen. Okay, so I'm going to do something different. No, you did 1/2, right?
1/2 and 1/20.
Now, I'm sorry, I need to annotate, turn this on. Okay, so here's 1/2 right here, right?
Mm-hmm. And that's the whole series?
That whole series will add up to 1/2.
Uh-huh.
That's the way, but the one you gave before was this one, right? The 1/6, 1/12, 1/20th?
I actually have both.
Yeah, good. Oh, I misunderstood. I thought you said, how do you get two series? I misunderstood what you were saying.
So that classifies as two series?
Yeah, it's just two different, because notice that this series is 1/3, 1/2, 1/12, 1/30th. And then this series is 1/6 plus 1/12 plus 1/20th.
Oh, but I just use that to minus like 1/2 minus 1/6, 1/6 minus 1/2, 1/6 minus
Right.
1/12, and get to the next column.
Right, but here. These are two different series, because I'm saying 1/2 is 1/3 plus 1/12 plus 1/30th. Over here, I'm saying 1/2 is 1/6 plus 1/12 plus 1/20th. So different numbers.
Okay.
Okay, and I'm going to give you another one. Okay, would you agree that 2 times 1/4 is equal to 1/2?
Yes.
Okay, so here's 1/4, and this is a series that equals 1/4, right? So let's get rid of that 2 for a second. So I get 1/4 equals 1/5 plus 1/30th plus, actually, I don't want to use that. Don't want to use that one. Let's do a different one. Okay, so this is, we showed before that this was equal to 1, right?
Yes.
Okay. So if I multiply this times 1/2, and then multiply this side by the same thing, I get a new series.
And that would be the third column, isn't it?
Let's see what it is. It's going to be equal to 1/4
That is the fourth column.
plus 1/12. No, it's not that either. It's its own series.
Oh.
Okay, so I just took the series equaling 1, and then I doubled it, and I multiplied it by 1/2, and I get a series equaling 1/2. So you can generate many different series for the same numbers here.
Does that change the fact that I can generate new triangle by starting from 1/2 too?
No, the point is to find a different series, different ways to represent 1/2. And think about the number 10. How many different ways can we add up numbers to get 10?
9.
1 plus 9, 2 plus 8, 3 plus 7. We have a lot of different ways to do that, right?
Yep.
It's the same thing here. We have a lot of different ways to find an infinite series equaling 1/2.
Okay.
And so the way you want to think about this is really it's a computational device. It's a way to find series and a way to sum series. Okay. So Hannah or Eric, how are you all doing? Is this making sense?
Yeah, I was quite confused before, but
Yeah.
this demonstration here
Yeah.
makes a lot of sense.
No, it takes a while, and it's just a confusing object until, you know, like if you've never seen Pascal's triangle before, I think that can be a lot too. Okay. Hannah, how about you?
I get it now, but I am confused on one small part.
Sure.
Because when you're doing the 1/20th, I understand how it works through 1/60th and so on.
Right.
But if you're adding from the 1/30th and on, I'm having trouble specifically with that one.
Yeah.
Once I get down to 1/330.
So, okay. So when you do it with something on a calculator, are you saying, why does that work?
No, it's because I was just trying to follow the pattern that we used for the other ones.
Yeah.
But I can't seem to get it to work with this one.
So there's two issues. That's what I'm trying to get at. Do you know how to use the column to find that second? Using the column, you can understand why that works, right? Not understand why, but understand that the column tells me that this sum equals 1/20th. That you okay, good. Okay. Just want to make sure. Okay, that's what I figured. And right now that's the level that I want, but I'll answer your question since you asked it. Okay. I'm just going to use the first three terms, you know, plus dot, dot, dot. Those are supposed to be three dots. Okay. Okay. So then I go to the 130. I'm going to use red. And then I look at this. I'm sorry. I go to this 130. And then I say, oh, that's going to be 120 minus 160. And if you do the math, it'll work out.
Well, yeah, and I was doing that, but when I got to 1/140 subtract 1/130, that doesn't equal 1/130, at least according to my calculator.
Oh, this could be a typo then. I wouldn't be surprised. Let's see what this number should be. This number should be 1/, yeah, that's no way that's good. I agree with you that that's not going to work. I see what your question is. So it's going to be a typo. So it should be, let's do this, 105 minus 168. That was a good observation. So that's what this should equal.
Okay, yeah, because I kept getting caught in it. I was like, I can't be doing the math wrong. It works for everything else.
Yeah. And do you have an answer for this using your calculator? I can't get it. I have to think about it. I have to factor it.
1/280.
Yeah, so I figured that, thank you. And I'll repair that so that won't happen again. And this could even be wrong too, because they get 140 minus 280 should be 1/280. No. Maybe that does equal that. Does that work out?
Yeah.
Okay, good. Okay, thanks. Yeah, thank you for pointing that out. Yeah, that means you're understanding it. That's a good thing. Because when you find mistakes in something, that means, you're digging deep enough to figure something out. So good work.
Yeah, I just thought I was going crazy. I'm like, I can't do math anymore.
Yeah. Trust me less, trust yourself more. I just must have, copying this over, I just must have I'm not made to be an accountant or anything like that. Okay. Okay, does that help?
Yep.
Okay, good. I have one more group to visit, and then I'm going to call everybody back. Okay. So I'll see you in a bit. Hello.
Hi.
Hello.
Is it making sense to you? I'm sorry it took me so long to get here.
Oh, it's fine. So I guess I don't know if this was like the oh wait, like if I misunderstood this part of it, but for at least one of the series that equals 1/2 and 1/20th, can you literally just divide everything
Yeah,
by
yeah,
it? Okay.
yeah, yeah. And then I don't know if you use, I made a mistake, and rather than, so let me just show you what it is. I hope it didn't affect your computation. Somebody found it, and
Okay.
I just took transcribing right here. Are you seeing the triangle?
Yeah.
Yeah. And hopefully this didn't affect what you were doing. Oops, wrong one. That one was right.
Oh, I see.
This should be 280. So if you were using that for anything, you would have been off.
Okay, yeah, I hadn't written that part yet. So
Yeah, that's right. Yeah. Yeah. So like, for example, if I wanted to find a series for 1/10, I could start with that. Is this what you were asking?
Mm-hmm.
Do you understand how the mechanics of the table?
I think so.
So you can use it as like a black box. I mean, I think of it like a calculator. I mean, you don't have to understand why the calculator works.
Right.
Okay.
I mean, it's pretty cool, actually.
I think it's amazing. I think everybody should learn about it. It's one of my goals in life. Anyway, so if I multiply everything by 1/2, I would get 1/10. That's supposed to be a 10 equals 1/12
Mm-hmm.
plus 1/84 and so forth.
Do we know how he came up with this? Because this seems really profound.
He was a smart dude. I mean, he invented, along with Newton, calculus. Right. You know, I mean, those right. things. And you know, he, in some ways, I've read some of his work, and it's so hard for me to figure out. Part of it's because it's alien. It's just written in a different time, and part of it's just like a lot of really. I would like to say it's like my explanations that get overcomplicated, but it's like that. It's like I don't really want to put myself in the same category, but it's like that on steroids. You know, it's
right.
Just people. I'm not saying this about myself, so I'm not. But sometimes really smart people can make things very simple, but sometimes because they think in really complicated ways,
right?
What they come up with is really, really complicated. You know?
Yeah, I know what you mean.
Yeah.
That makes sense.
Yeah. So anyway, well, good. I was going to call everybody back. I'm not going to go over the rest of all this stuff. Oh, by the way, how are you feeling?
I'm doing better, and sorry I had to bail out of the addition thing yesterday, but yeah, it's just been because so I guess long story short, my dad runs a construction business, and he was running a job down in Lake of the Ozarks. And so he was working there for a week, and one of his workers was going out to like bars and strip clubs every night without telling him. And they're like 1 in 3 people are testing positive in Missouri right now. And this guy and my dad didn't leave the house either. I mean, he slept every night. He slept in the house and stayed there and to, not to get COVID. And so he didn't know that this guy had been doing this. And then my dad didn't know he was sick until he had already gotten back.
Wow.
And so he brought it back to all of us. And so, but we're definitely through the worst of it now, and I'm feeling quite a bit better today. So it's brutal.
Yeah.
I can see why. I mean, and we're a pretty healthy group of people. I mean, I go rock climbing 4 times a week, and this thing has me like wiped out. I can see where if you're not as healthy or if you're older, where this thing can be deadly. So
yeah,
very impressive, I guess, and I don't say that lightly either. Yeah. But
and your folks are okay?
Yeah, they're okay. Yep. My mom put up the Christmas tree yesterday.
Oh, good. Yeah.
My mom and dad did. So they're doing quite a bit better. But
and I'm sure you've read all the stuff about how you should not go back to your present physical activity right away, but do it really slowly.
Yeah.
Yeah. So no rock climb. I know people.
Yeah,
I don't need to tell you. I don't need
Yeah,
to.
I will not be overdoing myself climbing anytime soon. So
Yeah. Well, good. I'm glad. I'm glad you sound good. So I'm glad. Yeah.
yeah.
Okay.
Yeah, I'm glad you're feeling better. That's a crazy story.
Yeah.
Yeah. I appreciate that, and everybody's been really helpful, and
Wow.
our family's been making grocery drop-offs for us and stuff. So I'm very thankful for all of my loved ones that care about me and friends and all that. So
Good. Yeah. Well, that's good. That's good. I mean, maybe that's a good side to some of this stuff. Is just getting a reminder of that.
mm-hmm. Yeah, definitely.
Okay. Well, I was going to go back and then bring everybody back in, and but it sounds like this. It sounds like this thing is making sense.
Yep. Yeah.
Good. Okay. Okay. So I'll see you back in the main room in a minute.
All right. See ya.
Okay, it looks like everybody's back. I'm just doing a quick screen share, and then I'm going to talk for a minute, and then we'll share the screen again. Notice that are you seeing the triangle? I had a typo on there, which somebody found, so I'm grateful for that. Hannah Richardson found that, and then Hannah Horwitz found another typo earlier in the course. I'm always grateful when people do that. Anyway, so that should be 280, and then everything works out. Somebody discovered that wasn't correct. So I apologize for that. Okay. Okay, I'm going to stop the share for a second, and then I just want to talk and then come back. Okay. Okay. So I'm glad that I waited writing up the problem set, because the problem I wanted to put on there, we're just not going to get to it today, and that's fine. I'm not too worried about that. So I'll come up with something different. I wanted to go over the stuff at the end because I think it's really, really interesting, but it's just, we just don't have time. But basically, it was to sort of look at integration by parts. So I'm talking about number 4, 5, and 4 and 5, or at least Leibniz's version of integration by parts, and I use that to sort of find out derivative formulas. I think it's really cool, but it's just not going to happen today, at least. So I apologize for that. So we're just going to focus on Leibniz for the triangle. And it sounds to me, well, first of all, any comments about it? I just want to go over questions 2 and 3, and that'll be the end of class, but I want to hear if there's any questions or comments. I'm hoping a couple of people, I don't know, hopefully they weren't just humoring me, but we're kind of impressed by this triangle and how Leibniz figured it out. And so I want to talk about that in a minute. But I just think this is a really cool object, and you don't see it very often. And one of my life's goals is to make more people aware of this, because I think it's as interesting and as important in some ways as Pascal's triangle. And there's going to be a way that this relates to Pascal's triangle that you're going to see on the problem set. So it's connected. And if you think about it, this is made recursively. Pascal's triangles made recursively by adding previous entries. If we wrote this as a triangle, you'd see kind of the same procedure except for fractions. So it shouldn't be surprising that they're equal. As a matter of fact, let me do something right now, and then I'll get back on task. Okay, I'm going to just do a screen share. Are you seeing a different version of the triangle that looks more triangular?
Yes.
Yeah, I did it this way because of the way I did it, just for various reasons. But if you notice, this triangle here looks a lot like Pascal's triangle. There we go. You know, except we start with reciprocals here. And notice that you start, if I want to find 1/6, 1/6 is equal to 1/2 minus 1/3. 1/12 is equal to 1/3 minus 1/4. So we can construct this the same way that you construct Pascal's triangle. So to find this entry here, I do this subtraction right here, 1/2 minus 1/3, and I get 1/6. And then I can build the next row. And then to find this one, it's 1/3 minus 1/12. I'm sorry, 1/3 minus 1/4, which is 1/12. To find this one, it's going to be similarly 1/3 minus 1/4. So it's a slightly different procedure, but it's analogous. However, when you do it this way, it's much harder to sum series. But I think seeing it both ways is interesting. And if you go to the readings for this week, you can, there's a clear link to that if you want to look at that. And when you do the problem, I'm going to put the problem, I'm pretty sure I'm going to put on the problem set. In fact, I even give you a web link in the problem for this. And so you'll see it. And so basically, these are I think if I'm doing it right, it looks like these are slant columns, and that's the way that you sum things. Okay, does that make sense? Okay, so enough of that. Okay, so I don't have much time left, but I do have time to finish up, so I'm going to stop the share. So I think people got a good sense of using this as a calculational tool, and it really is a calculational tool. And so what I want to do is I want to sum this stuff up. Let me find, sorry, let me share. Okay. Okay, so you're seeing the triangle?
Yep.
Okay, now notice if I multiply this by 1/2, I get 1/2 plus 1/6 plus 1/12 plus 1/20. So I just multiply. Now, do you see this anywhere in the column? Do you see a column that has these entries?
Second column.
So I'm going to add up all this stuff, and what does that equal?
1.
1. So what does this series equal? Multiply both sides by 2. I'm sorry. I'll do it from over here. And notice I get 2 is equal to 1, 1/3, 1/6, and so forth. Those are the reciprocals of the triangular numbers. So getting back to where we started, that was Leibniz's assignment. So imagine that you're teaching, and then I ask you to sum those numbers, and you come back, your answer is this whole triangle. And I say, what is this? And you say, you teach it to me, and I'm like, what? You know, and then I would react just the way that you all reacted. And it would take me a while to kind of figure it out. And finally I'd say, oh, I get it finally. You know, why didn't you just tell me simply? So that's kind of what I imagine that Huygens' reaction was, is that he gave his would-be pupil a very simple problem, and then Leibniz came back with this. And this solves not only this problem, but it solves infinitely many other problems. Imagine if I give you a problem that's, find a sum that adds up to 2/3, find a sum that adds up to 5/6. You can easily use this to generate series which are going to equal that number. So it's what it is, it's a tool for finding answers to infinite series. And so, I've read that he thought that he could actually solve all infinite series with this object. And if you think about it, given this, but the problem is there's lots of different ways to add numbers to get a result. Like, how many ways do we have? We have infinitely many different ways to get the number 10 if we want to find two numbers that equal 10. So you can imagine that this isn't that surprising that we can find all these different ways to find a series equal to 1/2. So to me, it's a pretty astounding answer to that. And it just shows kind of, someone asked me how he came up with it. And my sense is that he might have discovered this was this series here was telescoping. It seems to be reasonable. And then he just ran with that idea. And he said, well, I can build a whole series of series, like a list of lists or something like that. So I can build infinitely many series using that telescoping idea. And apparently thinking about how things add up together helped him figure out what integration was, and that got him thinking about calculus. And so one theory is that this is what sent him along the path that helped him to invent calculus. So anyway, my time's up. So I don't know. I hope you enjoyed this. I just think this is really cool. And like I say, I'm going to adjust what I was going to do on the final just a little bit, just to reflect that we didn't get as far today as I wanted. But I think we really got a good treatment of this. And I think it's a real insight into into how Leibniz thought, and just his genius. Okay. So that's all I got. If you have any questions about anything, stick around. Otherwise, I'll see you Thursday. We'll talk a little bit about Newton and a little bit about the argument that Newton and Leibniz got into. And I'm sorry my hope originally, as you know, was not to have classes this week, because I know you're really busy, but it just didn't work out, and I apologize for that. The problem with this course is there's always much more to cover than I can possibly cover. So. Have a good couple days. I'll see you Thursday.
Thank you, Professor. Bye.
Thank you. My pleasure.
Thanks, Dr. Alexander.
Certainly.